Hi, and welcome to another C Sharp training. I'm Jerry, and today we're going to do some loops and arrays. So let's jump into the training. We'll create a new project for this so that we have a clean one. So we'll be like loops and arrays. Okay, so C Sharp, Visual Studio created a new project for us, the same default file that we have. Of course, we need to set this up as the startup project so that we can work with it. And we're going to start with arrays first. Because we did some loops earlier, we did some conditional statements, we got to know how to construct a conditional statement and played around with it a bit, and we got to know two loops. One is the while loop, and the other one is do while loop. So they are kind of similar to each other, but they have some differences. And before we get to know another type of loop, I would like to actually show you the idea of an array. So if you ever worked with an Excel file or with Excel, then you should know what's a table. And even if you didn't, then you should have a slight idea what's a table. So an array is more or less like a table. Maybe let's just have an example, a visual example. So we have an Excel file, and here is a visual example in Excel. That would be an array. So we have a predefined region where we have like 1, 2, 3, 4, 5 spaces, right? So 5 spaces, and we can put stuff inside. The difference between Excel and C# and programming is that in theory in Excel you can put anything there, right? So we have this logical value here, right, and then a number here and some text here, right? So we can make some more text here. Now in C#, in theory, you could do that, but usually an array holds elements of a certain type. So normally that will be something like this. So this would be an array of int elements, and as everything in C#, when we create something like an object, so when we create variables, it should have a type and it should have a name, right? So you should already remember that. So this array it's an array of int elements named int r, right? And it has a fixed width, right? So these three things you should remember. So we need one type of element inside an array, it needs to have a name, and the array has a fixed width. Okay, let's jump into the code and see how we implement an array. So we want an array of elements of type int. So we say int, and then we say just an array. So that's how we denote an array. So now this whole thing is a type. It's an array of elements of type int. Currently, it does not have any size, so I can call it int r, right? And I've just declared an array of int elements. It's yet currently not assigned yet, but we will assign values to it in a second. So now, what we can do is assign a value to it, right? And to do so, we can define the array on the fly, either way, or define an empty array, right? Either way, we still define the size of the array. So if we wanted to create an array of what it was like 6 elements, right? We would say new, and then int array, and then define the size 6, right? So it will hold 6 elements. We can also, as I said, define the array on the fly. So we can just say like int arr, right? So the name of our array, and say new int array, and then define elements in those curly brackets, and then we can say like, okay, 1 2 1 2 2 come on, 3 4 5 I can't type, I don't know, something's wrong with me. Okay, yeah, and just define the elements inside, and this already puts those values in each placeholder, each field of the array. So the second option would be something as if I did something like this. So let's just copy this right somewhere here. Right, it's just as if I would do like 1 2 3 4 5 6, something like this. Make it like this and it. Yep, very nice. So that's the second option, right? So I defined an array and I already filled it out with some values, right? Okay, so that's how we define the arrays. Unfortunately, when we have the array and we want more elements, then we have to redefine the array. So an array is it's a good placeholder if you want to hold a certain amount of elements, but it's not as good of a placeholder if we don't know at the beginning how many elements we will have. Then we just have to imagine how many elements we would have and then create an array that would hold at least this amount of elements. Yeah, so that's one thing. Now, to be able to actually see the values of the elements within the array, we can call each element of the array as so. But before we do that, I'll try to do something that, well, I really would like you to actually always try whenever you try something, just to see what's inside. So I'll try to print the array on the screen, and doesn't get me any error, so that's kind of good, right? And we'll see what this gets me. Great. So the text representation of a whole array will just be like, okay, it's an array of ints. That's it. So it will tell me, okay, it's an array of ints. Okay, but that doesn't actually give me the values inside. Okay, so let's call this text representation of an array. Yeah. Okay, but I told you we can access each element in the array. Yeah, because we can put those square brackets here and then say the index of the element. And those indexes start from a 0, so this element should be on the 0th position, this should be on the 1st position, this one on the 2nd, 3rd, 4th, and the 5th. So if we want to see the number 5, we should choose the element on the 4th position, like 0, 1, 2, 3, 4. So the element with the value 5 should be on the 4th position. If we run this, we can see, yeah, okay. So now this is something important. So each array in C# has the index based on a 0. Yeah, and that's in C#. The array is created in C#. This is not true for, well, okay, it's kind of true because well, don't worry. We'll jump into Excel later on, but Excel is actually indexed with the base of number 1. So you start counting stuff with 1, not 0. But here, everything is indexed based on 0. So yeah, if we want to see the 0th element, so we put a 0 here, then we'll get number 1, right? So let me just type this here, element at at index 0, and like this. So yeah, so element at index 0 is equal to 1. And of course we could create a while loop, and we will do so. So we'll create a integer I, which will start with the value 0, and then we'll say the while loop, and then while I is less than 6, because we have 5 indexes, then we'll print out this, right? Okay, but here we'll actually put I, so plus I plus like this, and then put I here as well, and we'll put this so it's nicely formatted. Okay, so now we should, oh, I've just created an infinite loop. Okay, who knows what I did wrong? I just created an infinite loop because I is equal to 0. Is I less than 6? Yes, print. Is I less than 6? I is still 0. Yes, print. And so on and so on and so on. I just created an infinite loop because I forgot to increment I, right? Yeah, and actually, let's see how long will my computer actually last with this, because it should present me with an error at some point. Please do so. Come on. Yeah. If I go here, maybe it will actually get to know that. No, it's not really getting to know that. Oh well. Sometimes Visual Studio actually tells me that it thinks that the program I created went into an infinite loop and, well, it's not responding. But it's actually responding because it's printing something, so it won't probably do anything. Okay, but I should have this I++ here. And yeah, and that's the result of printing out the contents of the array. Of course, it's not really nice. I mean, it doesn't show me much, but at least I have the contents. And of course, this the first line is doubled because I said print out element at index 0 as the first thing I wrote, right? So yeah. Okay, what if we have an array and we don't know how many elements we have in there? So, like, okay, it's not an array that we created, it's something that we got out of, I don't know, another program, another source, somewhere, data source, right? And we just don't know how big is the array, so we can't say like, okay, I is less than what? I don't know what's the size of the array. Now you can actually get to know the size of the array because there is this property, and that's a second word that you should get to know, is the property. So the array has length, and properties are marked different than methods in this IntelliSense. So it just, well, in my Visual Studio it is a wrench, but in the other distributions there is another icon. So yeah, but this is a property, and it gets a 32-bit integer, so an int, that represents the total number of elements in all dimensions of the array, right? Don't worry about dimensions. It just tells you the total number of elements, so the length of the array, right? So if I do like this, I still get the contents of my array printed out, and it doesn't matter how many elements I have. So I can put 11 here, 23, negative 76, and 5 again, right? And if I print that out, I get all the elements, right? So this is convenient, going through a loop, right? And then printing out those elements. But, well, I had to write, well, this loop to actually loop through. And, well, this loop is okay. I mean, I use it quite a lot. And it's quite convenient for me to use it. Sometimes I use a different loop. So, and going through an array and doing something with its elements, it's called iterating. So iterating an array with while loop, okay? And, whoa, not this. I want to comment this out now. Okay, and now we'll see another loop, and so I need to use a different variable. So not I'll use j. So int j, right, equals 0. And let me just write the code first, and then I'll tell you what it is and how it works, okay? Because that will be a bit easier. Okay, so I have the code now, and now what I wrote is like, okay, I declared j and started it with 0. Then I have something that reminds this condition, is actually this condition, right? And then I have this j++, which was here, right? So the structure of this loop is actually the same, because I first initialize and declare a variable, right? So I declare it and then assign it a value, that is the initial value of this variable. This variable will be used to actually access each element in the array, and knowing that all elements are numbered from 0 to and then they increase by 1, then I can go through each of them, right? I know the length, so that's the condition for which the loop will be running. So the for loop is just a simplification, or putting the while loop in this form, as it was earlier, in a more structured form. So this structured form is actually the 3 parts, is like initialization, then the condition, and then the step, right? So this would be the incrementation, decrementation, or change, because here you can have any expression that will actually statement, any statement that would change something within the one run of the loop. And this run of the loop is called iteration. I want to say that word. So this part, this j++, will create a change in the loop in one iteration, so one run of the loop, right? And then how this goes. So initialization goes only once. At the beginning. Then the condition is checked. Yep. And then the step is evaluated. Oh, sorry. Yeah, because here we have another part. Is the loop. What did I call those? Loop operations or loop process. Or loop body, right? Or let's just call it body. So whatever the operations, the things that we want to do within the loop, right? So the condition is checked so that we know whether we should run the loop operations or not. So whenever this condition is true, all those operations in the loop's body will be performed. If this condition is false, then these operations are not performed. Then the step is evaluated, right? And the condition checked again, and so on. Right? So these are the 3 steps of loop, and these are the 3 parts of the loop, right? And the 4th one is just the loop body. So that's how this whole loop works, and I hope you kind of understand how it works. Now there is the 4th loop. The 4th, we have a bit less control. Okay, there is lots of control, but over that loop. But okay, in the beginning, when you start programming, you'll think like, okay, this is actually really a really handy loop, because you don't really need to know the length, and you don't really need to access anything within the array and so on and so on. You just get this straight out of the box, and it's like really convenient. So let me just show you this loop. So there is another one, and let's just look at it now. Okay, let me write the code really fast. So yeah, I commented out the for loop, and now we have the last one. So it's called the for each loop, and what it does is just looks at all the elements here, and then goes through the array in its way. And currently I'm just not going to explain what is its way, but it's just going through each element, and then puts that element in this variable so that we can use it, right? So when we write this, run this code, and we still go through each element, so 1, 2, 3, 4, 5, 6, then 11, 23, negative 76, and then 5, right? So we go through the whole array, and then we can use those elements in the array. One thing that we miss here is we don't know what index is that element, right? Of course, we can calculate that. We can have another iterator, another variable that we will increase, and so on and so on and so on, and get to know what is the actual value of the index, and that might be correct, but well, out of the box with this for each loop, we just don't have this value of the index within the array. We just have this element that actually contains the value of the current element being accessed in the array, because the for each loop just access each element, right, and gets you that particular element and none other, right? Something like this. Okay, so we now know more or less how to create a small array, right? And we know how to iterate through it more or less. So we have 2 ways of going through an array. Now, I want to show you one more thing. Oh, okay. Maybe that will be on the next lesson. The next lesson will just be a cool game again, but this time I won't ask you to create this, but I'll just try to write this, and then maybe we'll be extending this. So okay, maybe just let's wrap up this right here, and we'll be continuing with the next video. So thanks for watching, and have a good day. Cheers.